Linear combinations. Let me unfreeze this. Linear combinations is a method we use for solving systems, and we use linear combinations, which is called elimination method, when we can't solve for one of my variables easily. So I have coefficients in front of all my variables as I see here. Now, I think the probably biggest struggle that people are having is knowing what to multiply by, how to get the opposite coefficient. So I want to just redo that real quick. So if I look at problem number 2, can I easily get 2 to be 7 or 7 to be 2? Can I make that exact? No. Can I easily get 5 to be 15 or 15 to be 5? Yeah. What can I do? How can I get 5 to be 15? Right, times 3. So I recommend that when you're doing these problems, first focus on just the numbers. Okay? So I want my number in front to be the same. So I know that 3 times 5 will give me 15. Now, after you've gotten the number the same, look at your sign. I need 1 to be positive and 1 to be negative. Well, if I look here, I have exactly that. 1 positive and 1 negative. Alright, so if I go ahead then and multiply out my 3, then I would have opposite coefficients.
Speed dating.
What? Speed dating, we're doing it today. See? Speed dating. Math version.
It sounds weird. Thank you for trying something new. You're great. Let's see if the results on the quiz show.
Why isn't it going away?
Because it's weird.
Now there is no challenge for this. Okay, so for number 2, we only had to multiply one of my equations, right? Let's take a look at number 3. Can I easily get 2 to be 7 or 7 to be 2? I should hear a collective answer from everyone. Can I easily get 2 to be 7 or 7 to be 2? No. Can I easily get 6 to be 8 or 8 to be 6?
No.
No. Unless I multiply by a fraction, I can't get those to be the same. So this is an instance in which I'll need to multiply both equations by something. So when we have this, we just multiply by the other one. So my top equation, so actually let's decide, do we want to get rid of x or y? We want to get x? Okay. So getting rid of my x's. When I need to multiply both equations, I just multiply it by the other number. So my top equation, since I'm trying to get rid of my x's, I'm just going to multiply it by 7. And the bottom equation, we multiply by 2. Now, again, first take care of your numbers. Now I will have 14 and 14, but I need to make sure one's positive and one's negative. Right. Starting off, they're both negative, so I need to turn one of them into a positive. You want to do the top or the bottom? Bottom? Okay. So since it's currently a negative, instead of multiplying by just 2, what can I multiply by to make that positive? Right, because a negative times a negative will give me a positive. So again, first look to see, are my coefficients the same? Do I have opposite coefficients? If not, then look to see what can I multiply by to get them to be the same. Sometimes you have to do just one equation, sometimes you have to do 2. Alright, let me throw up some more examples. Okay, so let's just use this example. Let's say that this is given to you and you're supposed to use linear combinations. What would I want to do? Would I have to multiply both equations or just one equation? Someone other than Drake. Someone other than Drake. What would I need to do? Can I easily get 2 to be 5 or 5 to be 2? I can do one? Yeah, what can I multiply 2 by to get 5? Right, it would have to be a fraction, so I can't easily do it. Can I multiply 3 by something to get 12 or 12 to be 3? Yeah, what can I do? 4. So I'm going to multiply my top equation by 4. Now now that I have my numbers, I need to check my signs. I have 1 positive, 1 negative. That's good, that's exactly what I need. So that would be my first step. Alright, questions on that? Okay, let's say I change this, and we had, Alright, can I easily get 2 to be 5 or 5 to be 2? No, okay, so get 3 to be 7 or 7 to be 3. No, so I need to multiply both equations. What do we want to get rid of, x's or y's? X? Alright, let's do it. What do I need to multiply my top equation by? 5. Since I'm trying to get rid of my x's, I multiply by the other number. And then my bottom equation I'm going to multiply by 2. Okay, now we have our numbers the same. 5 times 2 is 10, 3 times 5 is 10. But I need to check my signs. Right now they're both negative. I need one of them to be positive. So Q1, how am I going to do that? Right now they're both negative. I need one of them to be positive. What can I do to make one of them positive? What can I multiply a number by to make it positive? If I have negative 5, and I want to multiply this by something to get positive 5, what do I multiply by? What is it? Yeah, another negative. Negative times a negative is a positive. So then Q1, let's say I want to make my top equation positive here. Instead of multiplying by 5, what would I multiply by? A negative times what gives you a positive? Yeah, so this would be negative 5 here. So again, this is the first step. Check to see if your coefficients are opposite. If not, then you need to figure out what you have to multiply by. Get your numbers to be the same first, then worry about your sign. Okay, questions on that?
Why do you have to change it to
Because if I had just a positive 5, when I would multiply this out, I would get negative 10x, and then yada yada yada. When I'd multiply this out, I would get negative 10x, yada yada yada. But what's negative 10x plus negative 10x? Be negative 20, right? We want it to cancel out. We want to eliminate it. We want one to be positive, one to be negative. Because if I added this all together, let's actually go ahead and do this. If I were to multiply this out, I'd have 15y. 7. And this would be 14y. If I were to add my greens together, I would get negative 20x plus 29y equals 84. And did that help me solve for a variable? I still have x and y. I'm trying to get rid of one of them. So I need one of them to be positive and one of them to be negative. Because if I were to accomplish that, so if I were to have that negative in front, that would make this a positive 10, a negative 15, and a negative 70. So then positive 10 and negative 10 would be 0x. That would cancel out. And then here we would end up having negative 1y. And 70 minus 14 would be 56, negative 56. So then now I could solve for y. I would get that y is 56. So here I get an actual number, whereas before I'm left with an x and a y. I'm nowhere closer to my answer. So I want my numbers to be the same, but the signs to be opposite. Alright, other questions on this? Alright. So let's continue with this problem then, since we're doing it here. Alright, so y equals 56. Now that I know that y is 56, what would I do to find x? Yeah, take this and put it into my original equation. It does not matter which original you use. Take and put it back into your original equation and solve for x. So we get 2x negative x plus 3 times 56 equals 14. Let's see. 3 times 56 is 150 plus 18, 168. Equals 68 minus 14 would be 64, 54. And dividing it by 2. 77. Alright, so then my answer would be 77. 56.
using a calculator.
Use math.
Alright, so again, for elimination, because your quiz today is on this method, linear combinations, eliminations, that's why we're reviewing it right now. We want to get opposite coefficients. Once we do that and we add it together, it should eliminate one of my variables, allow us to solve and get an actual numerical value, an actual number. Then we just take that and put it back into a variable. Alright, questions on that? Okay, so now that we've gone over that, I want you to do this other warm-up problem. We'll just do one. Alright, I want you to do number 3 here. We've already got you started off with knowing what to multiply by, so why don't you go ahead and finish up number 3. And I want to see every single person working on this.
So you got a piece of paper?
Feel free to work with the person next to you. After this will be our speed dating activity.
You get a string and you go on, you do math with Alex and you do math with Jose and you go on, you do math with Tanya.
That's great. You do math with so many different people. Speed dating. Here it is. It is freaking out right now. Hey, Sean, what'd you do? Looks like the screen on the scary movies. Mm-hmm. Okay, let's take a look at this here. So now that I know what to multiply by, what do I have to do with these numbers? Distribute them. Yep. So, alright, I'm going to go and rewrite this one over here. So 7 times negative 2 is negative 14x. 7 times 6, 31. Equals, 30. What's 7 times 6? Thank you. Alright, equals 42. 2. Do we get that for our first equation?
I think it.
Alright, and then our second equation, -2 times -7 is positive 14x. -2 times 8y is negative 16y. And -2 times -5 is positive 10. Alright, so when we add these together, my x's cancel. And let's see, 42 minus 16 would be 32 minus 6, which is 26.
Is it positive?
Since my 42 is the larger number and that's positive, then this is positive.
What if I did it like negative figures?
What if you did what?
What if I did like the top I made positive and the bottom I made negative?
Then you would have negative. Do you have negative?
I thought it was negative figures.
Does it make sense?
And then the top, yeah.
Yeah, so you would have negative.
Is that wrong?
What did I miss here? 50. Is that what you guys said? Okay. So then divide by 26. And what's 52 divided by 26? 2. Good. Okay, so now that I know y is 2, what do I do? Put this in for y, my other equation. So negative 7x plus 8 times y, which is 2, equals negative 5. We solve for x. Subtract my 16. Negative 7x equals negative 21. Divide by negative 7. And what do we get for x? Yeah, 3. Am I done though? What do I have to do with that?
In the form.
In the ordered pair form. 3, 2. X comes first, then 1. Alright, questions on that? It does not matter. Ivania asked a great question. She said, when we go to solve for x, doesn't matter which equation I use, and it does not. Just use one of your originals. Other questions?
Any questions on the quiz?
Just 2. Because they're so long. They're so many.
Yeah.
They're like 5 points apiece. So you can get. Okay. So next we're going to do our speed dating math style. Let me pause this. Okay, so today is just more practice with using substitution, eliminations to solve our systems of equations. But today, instead of being given the equations, we have to write them. So we have word problems for today. And we throw in word problems for pretty much every single unit, just to kind of get you used to having to read and interpret some information to come up with the problem. So it's nothing new that we're learning. We're just taking what we know and applying it to a situation. All right. I think actually I want to start off with, let's flip it to the back side. I want to do problem, let's do number 5 first. The very last one. Alright, so it says here the length of a rectangle is 3 more than twice its width. The perimeter of the rectangle is 36 feet. Set up 2 equations and solve to find the length and width of the rectangle. So far we've been doing systems of equations, which means we have 2 or more equations. So for these word problems, we're going to be having 2 equations. So 2 equations means we need to have 2 different formulas or 2 different totals. So reading through this, it says the length of a rectangle is 3 more than twice its width. Now, they didn't give us variables to use, so we get to pick it. I'm just going to use L for length and then W for width. You can use X and Y. That doesn't matter. And the perimeter is 36 feet. Well, how do we find perimeter? What is the formula for perimeter? Close. Add all the sides, yeah. Length times width is our area. Perimeter is where we add our sides together. So for a rectangle, sometimes it helps out to draw these. We have our length, we have our width, our length, and our width. So go ahead and draw this picture on your notes to help us kind of know what we're doing here. And as almost said, the perimeter is adding all of our sides together. So length plus width plus length plus width. What's another, how could we simplify this?
For 2, like,
Yeah, 2 lengths and 2 widths, right?
oh, that's works.
A little bit simpler of form, rather than having to write that all out. Alright, so again, we have to have 2 equations. They told us my perimeter is 36 feet. So I know my perimeter is going to be 36 feet. So great, I have one of my equations here.
So adds up.
Yeah, if I add my lengths and my widths together, that'll add up to be 36. But I still need another equation. So let's take a look at what they gave us. The length of a rectangle is 3 more than twice its width. Back in September, when you first started here, the first few days you saw us and got to know us, is when we did our verbal expressions here. So this is verbally stating the equation. What symbol do we have when it's is? If I say the length is, or let me do a different example. Yeah, equals. The length is, it's equal to 3 more than twice its width. Well, how can we interpret this? 3 more than? What does that mean? What is 3 more than? If Tayshawn has 3 more cookies
Plus.
than Trey, it is plus. Yeah, 3 more than.
Cool.
Right? And then what does it mean twice its width? Right, 2 times it, right? Twice is 2 times our width. So our length, the length is 3 more than twice its width. So 3 plus twice its width. Or you could write it as twice its width plus 3. Right, either way. So they gave us that equation just in words. Okay, so there's my other equation. We have an equation for length, and we have an equation with our perimeter. I'm going to go ahead and take this guy. I was hoping it would move, it's one thing. I'm going to put this here. Okay, so now we have 2 equations. Now we need to solve. So set 2 equations, we've done that. Now solve to find the length and width. So we could do either linear combinations or substitution. What would you guys like to do? You want to eliminate? You can. I would recommend substitution though. Why? In substitution, what's our first step of substitution? Let's say that I was doing this problem over here. If I were to do substitution here, what's my first step? What do I have to do? Right, I have to get a variable by itself, right? In my equations here, don't I already have a variable all alone? It's already solved for L. So they've already done some of the work for it. So I can just take my length equation and substitute it in for L. You can do elimination, but we would have to rewrite this so that my L's are lined up, my W's are lined up, my constants are lined up. So you can do that. You'd have to subtract your L over and subtract your 3 over. But since it's already solved for L, let's just do substitution here. Let's just do it. All right. So we have 36 equals 2 times L, which is 2W plus 3. So this whole thing here is L. And then plus 2W. Any questions on what I just did there? Is there anyone that doesn't see what I'm doing? Okay, so I've just substituted in my length. Alright, now what do I do? Darling, what would I do next? Yes, we need to get rid of those pesky parentheses. Let's distribute my 2. So when we're distributing, Tayshawn, what is that going to give me? 4W, and then What would this give? Again, plus 6. Alright. Now that I've distributed, Abdul, what do you think we'll do next? Yes, very good. We can combine like terms. And Alex, which terms can I combine?
4W and 2Y.
Very good. 4W and 2W. You guys are getting much better at this. Alright, so we have 36 equals, what's 4W, 2W give us? Good, 6W. Plus 6. Alright, so now let's go ahead and solve for W. Tayshawn, what's my next step? Good, subtract 6. 36 minus 6 is 30. We have 6W. And those cancel out. What? Yes! That's exactly what we do, Kiwan. We divide! Right now it's 6 times W. The opposite of multiplying is dividing. And what is 30 divided by 6? 5.
55. Good job.
Just 5. Alright? Yeah, I prefer this one. But just because my W was on that side, that's why I left it. Alright. So now that I have W, I know my width. It is 5 what? What was the units? Good, 5 feet. So I know my width is 5 feet. So then how do I find my length? You take W and you put it into one of your equations. I'm just going to use my top one since it's already length equals. So I'm taking my width and I'm going to put it into my length equation. Alright, so length equals 2 times W. 5 plus 3. And 2 times 5 is 10. Plus 3 is 13. So my length is 13 what? And we must use our units. There are our answers. It's because I'm making you do every single step with me. Like, you beat me every single time, so it would only take like 5 minutes. Alright, questions on what we've done here? Okay. So again, it's the exact same process. We use substitution or elimination, but it's just now we have to actually write out our equations. Alright, let's take a look at the one that talks about nickels and dimes. Or nickels and pennies. Number 4? Is that the one above it? Number 3? Okay, let's take a look at number 3. Alright, you have some nickels and pennies. Together they add up to 65 cents. You have 21 coins total. How many of each coin do you have? Alright, so the fact that we see nickels and pennies, those are 2 different variables. We need to have 2 equations to be able to solve for both of them. As many variables as you have, that's how many equations you must have to be able to solve for. Alright, together they add up to 65 cents. Notice this is giving me a total. You have 21 coins total. Oh, another total. We are looking for our totals here. Because typically with these types of word prompts, they give us 2 totals and then we have to write equations for those totals. Alright, so nickels and pennies. Which one do you want to be X? Which one do you want to be Y? What do you want nickels to be? X. Alright, pennies? Alright. So together they add up to 65 cents. So my total amount, total value, is 65 cents, right? So I'm going to write one equation talking about my value. So the total value of my coins is 65 cents. So how do I figure out the value? How much is each nickel worth? 5 cents, right? How much is each penny worth? 1 cent. So if I found out how much all my nickels were and add that to how much all my pennies were, that would be the total amount, right? Okay, so nickels are my x, and we said nickels are worth 5 cents, so 0.05, right? 5 cents is 0.05. And my pennies are worth 1 cent, so 0.01 for every penny. So I'm saying 5 cents for every nickel, and I add that together to 1 cent for every penny. So the total value of my nickels plus the total value of my pennies gives me the total value altogether. Questions on that equation? Okay. So then our other total was the number of coins. Well, if x is the number of nickels and y is the number of pennies, then I can just say the number of nickels plus the number of pennies is the total number of coins, 21. So it's good to label what our variables are. X is the number of nickels. Y is the number of pennies. Otherwise, in the end, when you find your value for x, you're not going to remember what it is. Understand? Yeah, but it's good to rewrite. Okay, so look, we have our two equations now. One equation is about the total value, the cost of it. The other equation is about the number of coins. Okay, so we can do either substitution or elimination. We could do elimination here and multiply by, what, negative 0.05 to get my x's to be the same. Or we could do substitution and just solve for x or y. I personally, for these ones, prefer to do the substitution. So let's go ahead and do that. Do you want to get x by itself or y by itself? All right, let's get y by itself. So I'm going to cover up my y. What do I need to get rid of? X. And x is currently positive, so I need to subtract it. So I get y equals, and remember, look at the sign in front. My x is negative, so it stays negative. And 21 is positive, so that stays positive. So we should all be writing this down. Alright. So now that I have y all alone, now I can take this equation, and what am I going to do with that? I'm going to take this expression and put it in for y of my other equation. Okay, so let's go ahead and do that. So I have 0.05 x plus 0.01 times y, which is this whole huge expression, so I need to use my parentheses here. Negative x plus 21 and then equals.
How do you do?
What I do what?
Why do you solve?
Solve for both x and y. Because when I'm solving for one variable, the whole purpose of me doing that is so that when I substitute in, I have just one variable to solve for. So I could have solved for y and then solved for x, but if I would have plugged them both in, I would have just had y here and x there. I would still have both variables. So we only need to get rid of one variable, so we only solve for one variable. Alright, other questions so far? Okay, and darling, what do we have to do for this step? Distribute. Again, we're distributing. Whenever we have those parentheses, we can get rid of those pesky parentheses. You might need your calculator for this. So 0.05x plus, oh, that becomes a negative, doesn't it? Plus a minus gives me, plus a negative is minus 0.01x. And what's 21 times 0.01? What is 21 times 0.01? You Got a calculator. What'd you say? Very good, point 21. Alright, any like terms we can combine together, Tayshawn? Yeah, we've got a couple x's we can combine together. So let's combine those. 0.05 minus 0.01 gives me 0.04x, 400ths x, plus 2100ths equals 6500ths. Any questions so far? See people fiercely scribbling as always. Alright, so now what's my next step, Rachel? Yeah, good. We need to get x by itself. So I cover up x and to get rid of all these other things. So minus 2100ths. So I have 0.04x. Those cancel. Alright, so that gives us what? 0.44? Is that right? And then Abdul, what's my last step here? Very good, fine. So what's 0.44 divided by 0.04? You got 11? Okay. I was hoping we get a nice whole number because there are so many decimals in them. Alright. Now that we know x is 11, how do we find y?
Plug it in.
Plug it in, plug it in. Now, which equation would you like to substitute it in for? I'd probably go with the second one, right? Don't do it with all those decimals, those lots of things. So, let's do that. My equation is x plus y. And I now know x is 11. So instead of x, I have 11 plus y equals 21. Subtract my 11. And what is y?
Y is
10. Alright, now I don't want you stopping at just this for your answer because the question asks, how many of each coin do you have? So what was y? What did we say y was?
10.
Pennies, good. So we have 10 pennies and 11 nickels. So if I have 10 pennies, that's 10 cents, right? And 11 nickels, 55 cents, and 10 cents and 55 cents is 65 cents. That's what our first equation was the values of those. Alright, questions on that? Okay, so I know word problems are no one's favorite, but show me thumbs up, thumbs middle, thumbs down, how you feel with these word problems so far. I see 5 wonderful people holding up their thumbs. I want everyone to hold it up in front of them. Tayshawn, I need to see your thumb. I think Alex is giving me a hidden thumb signal. Jose, I want to see your thumb. Lavanya, I want to see your thumb. Okay, so I'm seeing a lot of middles. That's good. That means you feel somewhat comfortable, but you're still a little bit shaky with it. So let's go ahead and do another problem. Let's do the baseball glove one. I think that's number 2. Number 2? Alright, baseball season's around the corner. Nets are heading to spring training next month, right? Is it next month? Month after? You guys watch baseball?
No.
Sports at all?
No.
Just not baseball?
No.
No Bryce Harper fans? Jason Worth?
No.
No. Okay. Well, I know where I won't see you guys then at the baseball game. We'll just spend my whole summer there. Alright. So number 2 says a sporting goods store sells right-handed and left-handed baseball gloves. That is nice for those people that are left-handed. Don't we have some in here? Don't we have one? First grade, I guess. Alright, in 1 month, 12 gloves were sold for a total revenue of $561. What is revenue? Yeah, how much they made. Very good. Right-handed gloves cost $45. Whew. And left-handed gloves cost $52. They get you an eighth of your shoes, Sean. You can get 2 pinky toes. All right. So again, we need 2 equations because it says let x represent the number of right-handed. X is right-handed, and y is left-handed. So we have 2 variables. We need 2 equations. So again, let's look for our totals as we read through here. Okay, they sell left and right. In 1 month, they sold 12 gloves. We have a total of 12 gloves that were sold. So what was our total gloves sold? What's my other total we see? 561. What is 561? The total what? Good, total revenue, total moolah they got. Good dough. All right. All right, so let's write our 2 equations. We have one that's talking about the number of gloves. And then we're going to write an equation talking about revenue. All right, what was the total number of gloves that were sold? 12. And what do you think my equation is going to be? How do I figure out how many gloves were sold? What are my variables? What does X represent?
Right.
The number of right-handed gloves.
Same as the last.
And what does Y represent? The number of left-handed gloves. So the total number of gloves is how many left-handed were sold and how many right-handed were sold, which means we're going to add those together.
Just 6.
So the number of the number of right gloves plus the number of left gloves gives me the total number of gloves. All right, now our revenue. So our total revenue was 561. All right, so how are we going to figure out our left side equation? Our total revenue is the amount of money we got for my left gloves and the amount of money I got for my right gloves. Well, what equation can I set up to figure out how much money I got for my right gloves? My right gloves are X, right? What can I do here to have this represent the amount of money I made? Let's say that Trey sold 10 candy bars and he made $50. How much was each candy bar?
$50.
You sold 10 candy bars. And you had a total of $50 in your pocket afterwards. So how much was each bar? 5, right? So the number of bars times the value gives me the total amount I made, right? Same idea here. The number of gloves is X, so the total value is going to be the cost of it. See, right-handed gloves, it's 45, times the number of gloves. $45 for each glove. So 45 times X. And then similar for my Y's. So I have 45X. And then my left-handed gloves for $52.
We have
We have 2 minutes left.
we actually have 1 minute.
So again, we have 2 equations here. One represents the number of gloves. The other one represents the total cost or revenue. The amount each glove was times the number of gloves. not each one of those times 4 gloves. So again, we could use either linear combinations or substitution for this. You can use either method, whichever you prefer. And I'm passing out your homework to you. Yep. So this is practicing word problems and review of what we've done so far. Keep in mind we have one more lesson and then it's review time. Yes. So worksheet 8 is your homework for next class. If you have not done your e-card, do your e-card. I will hunt you down and force you to stay with me to do your e-card. Alright, so we've got our equations here. And we need to solve our system. So again, you can use either substitution or elimination. Either way. For this one, I would probably do substitution again, just because if I did elimination, then I'd have to multiply 12 by either 45 or 52, and that's a pretty big number. So I'd probably do substitution just to kind of keep the number small. But again, you can do elimination. Alright, so my top equation, x plus y equals 12, this one here, I'm going to use that to get either x or y by itself. And let's go and get y alone. So I have x plus y equals 12. So subtract x. Get y equals, again, my x is negative, so that stays negative. And 12 is positive, so that stays positive. Alright, now I'm going to take this equation and put it in for y of my other equations. Put it in for y here. Alright, so now I have 45 x plus 52 times the entire expression, so that's why it's imperative that we have this parentheses there, equals 561. We end up having to multiply big numbers anyways, that's alright. So I have 45x, we need to distribute, plus negative 52, so plus and negative is just minus 52x, plus 52 times 12, 520, plus 104, 624. Alright, so 644. Alright, and then equals 561. Okay, so we can combine like terms here. 45 minus 52. Alright, so that would be what? 7 negative 7x plus 624 equals 561. Then subtract my 624. And with some big numbers here. So we get negative 7x equals, and that would give me 3, negative 63. And divide by negative 7 on both sides. And I get x equals positive 9. Alright, so now that I've got x equals 9, I can take this and put it back into my original to solve for y. So I'm going to take this, put it in, and so let's put in for x. This is x. And then we're going to solve for y. So instead of x plus y, I have 9 plus y, since 9 is x, equals 12, and then subtract 9 to solve for y. Y equals 3. Now again, we need to state what these actually are. So x was the number of right-handed gloves, so 9 right-handed. Answer. And then y was my left-handed, so 3 left-handed. That's our final answer. Alright, so again, we have these two totals. We've got the total number of gloves and the total amount of revenue. And total number of gloves is going to be the left and the right add together. And total revenue is going to be the money for my left, which is just the cost times it, plus the money for my right was, which is just the cost times that, which gives us the total. Alright, let's go to number 1. Do that one next. Alright, a brother and sister took turns driving a 580-mile trip that took 10 hours to complete. Your brother drove at a constant speed at 55 miles an hour, and your sister drove at a constant speed of 60 miles an hour. Let x represent the number of hours your sister drove, and y represent the number of hours your brother drove. Write a system to find the number of hours each person drove. So again, two variables, x and y, we need two equations to solve for it. So they gave us x as the number of hours your sister drove. And y is the number of hours your brother drove. Okay, so let's take a look at our information. Again, we have two equations. We're probably looking for two totals here. So they took turns driving a 580-mile trip that took 10 hours to complete. So we've got the total mileage and the total time. So we're going to write an equation dealing with the miles and an equation dealing with our time. Alright, well, x is the number of hours, and y is the number of hours. So our x and y are representing the hours. So the number of hours your brother drove and your sister drove would just be x plus y, which should give us the total amount for 10 hours. And then for the how far they go, well, we're going to use our miles per hour to help us out here. Right, our brother, which is y, our brother, drove at a constant speed of 55 miles per hour. So that means 55 miles per hour would be 55 times y. Y represents the number of hours. So if he drove just 1 hour, he went 55 miles. If he drove 2 hours, he did twice that, so 110. So on and so forth. So the mileage that our brother went was 55y. 55 times how many hours he was driving. Then the mileage that my sister went. So our sister drove at 60 miles an hour. So this is again 60 miles per hour, 60 times x. Sister's x. Alright, so how far the number of miles my sister drove is going to be 60 times however long she drove. If she drove for 1 hour, that's 60 miles. If she drove for 2 hours, that's twice that, 120. So that gives us our mileage, and the total mileage, they said, was 580. Alright, so we have our two equations. That takes care of it. So now, letter B. Solve the system, state the number of hours each person drove. So, again, you can do either substitution or elimination. Since I did substitution the last couple times, I'll go and do elimination here. Alright, so I'm going to rewrite out my equations. 60x plus 55y equals 580. And then we have x plus y equals 10. Again, our variables need to be lined up. So, for elimination, I can get my x's to be the same, or my y's, I'm going to have to definitely multiply something. So I'm going to go and get rid of my x's. So I need it to be the same number, so I'm going to multiply by 60. I need it to be negative, so multiply by negative 60. Again, multiply by negative changes our sign. Okay. So let's go and distribute this out. So my new equation is negative 60x minus 60y equals negative 60. Okay. And then my top equation just will rewrite that. Right, and then add these together, my x's cancel. And then I end up having negative 5y left over. And 580 minus 6 would be 520. Okay. Alright, so let's take a look here. So now we need to divide by -5 to get y. I want to make sure I'm doing this correctly. Messed up something. Alright, I see my mistake here. -60 times 10 is not -60, but rather -600. Alright, so let's fix that. 580 minus 600 is -20. Alright, now let's divide that. We get y equals 4. Okay. Now that we have y is 4, take that value and put it back into my original equation to get x. So x plus 4 equals 10, which means that x equals 6. So again, we need to specify what this means. 6 represents, I believe, our sister. X is our sister. So my sister drove 6 hours. That's what the sister drove. And 4 hours is what our brother drove. So again, set up 2 equations. Typically, we have 2 totals that we have to use to help us create our equations. All right, so I want you to go ahead and try number 4 here. We have a card A and a card B. You're going to get a couple of different equations here. Let me help you set up the equation, then I'll have you go ahead and work on solving it. So it says you're offered 2 different credit cards. Card A charges $75 per year and 15% interest. Card B charges $15 per year and 18% interest. Let X be your average balance and Y your total cost after interest. And then write a system you could solve for to find your average, what your average balance would need to be for the cards to cost you the same amount for 1 year. Alright, so this is a little bit different here. We have card A and we have card B. Right, so card A. Card A charges $75 per year, so that's that one-time payment, $75, and 15% interest on your average balance. So interest on our average balance is going to be 15%, it's 0.15, times my average balance, and it says X is my average balance, so times X. Y represents the total cost after interest. So if they charge me 75 plus the interest, that's going to be my total cost in the end. So 75 is how much the initial amount is, plus the interest added to it will give me the total cost. Alright, so that's my plan for card, or that's my equation for card A. So let's take a look at card B. Alright, so B charges $15 per year and 18% interest. So again, they have a flat rate, but only $15. But notice their interest is higher, 18 cents or 18% on the average balance. So that's going to be card B's plan. Okay. So notice this type of problem is a little bit different in that we don't have 2 totals that we're dealing with, but rather 2 different plans we're comparing, card A and card B. All right. So it says write a system, and then part B says solve the system. State your average balance and the cost of the credit after 1 year. So solving our system here, it says write a system to find out what your average balance would need to be for the cards that cost you the same amount for 1 year. So we want to figure out when these 2 are equal, and that would be the average balance for the cards to cost the same. So here our setup's a little bit different in that, again, we don't have those totals, but rather that y is our variable that's equal to. But we still can solve this either by substitution or elimination. My recommendation would be substitution. It's already solved for y, so take this whole thing and substitute in for y. So we have 75 plus 0.15x equals 15 plus 0.18x. Then go ahead and subtract and move your x's together and get your constants together. Solve for x, substitute back in, solve for y. So you go and give that a try, and then I'll write up the answer up here for you to check and see if you got it right. Also, remember the key for the notes is posted on Blackboard. You can always check your work with that as well. Okay, so you should have gotten x equals 2,000 and y equals 375. But we need to know what that stuff means. So x represents the average balance. So $2,000 has to be our average balance. And then it says that y represents total cost after interest. So again, that's also dollars. That's our total cost. So again, what we just found out is that between these two cards, even though they charge different amounts of initial fees and interest, when I have a $2,000 average balance, the cost will be the same, and that'd be $375. So kind of expensive cards there to have. Just pay cash. All right, so again, your homework is going to be worksheet 8, and you will have a mini quiz next class over special cases and word problems. And then just a reminder, next class is our last topic, and then it's review test. All right.